this session, we discuss about the radio waves and its propagation. The propagation of radio waves is affected by atmosphere, which will be discussed in detail in this session. In communication, all types of information is converted into radio frequency signals, and they are transmitted by transmitting antenna and received by receiving antenna. Radio frequency signal are commonly known as RF. RF are radio waves, which are electromagnetic waves of frequency range from 500 kHz to about 1000 MHz. They are used in wireless transmission, audio, television broadcast, cordless telephone, cellular phone, cable TV, satellite TV, data in the form of Wi-Fi, Bluetooth, 3G network, 4G network and advanced network in communication system. During the propagation of radio waves or EM waves from the transmitter to receiver, there are several factors which affects the propagation of EM waves. Due to this, the strength of the wave keeps on decreasing. The atmosphere of Earth plays very important role in the propagation of radio waves or EM waves. Now we are going to discuss the composition of different layers of atmosphere. There are 5 layers. They are: the first one is troposphere. The troposphere starts at the Earth's surface and extends 8 to 14.5 kilometers high. This part of the atmosphere is the most dense. Almost all weather is in this region. The second, stratosphere. The stratosphere starts just above the troposphere and extends to 50 kilometers high. The ozone layer, which absorbs and scatters the solar ultraviolet radiation, is in this layer. The third, mesosphere. The mesosphere starts just above the stratosphere and extends to 85 kilometers high. Meteors burn up in this layer. The fourth, thermosphere. The thermosphere starts just above the mesosphere and extends to 600 kilometers high. Aurora and satellites occur in this layer. The fifth, exosphere. This is the upper limit of our atmosphere. It extends from the top of the thermosphere up to 10,000 kilometers. Now we are going to discuss the ionosphere. It has very important role in the propagation of radio waves. The region gains its name because the air in this region becomes ionized by radiation, primarily from the sun. The ionosphere is an abundant layer of electrons and ionized atoms and molecules that stretches from about 48 kilometers above the surface to the edge of space at about 965 kilometers, overlapping into the mesosphere and thermosphere. This dynamic region grows and shrinks based on solar conditions. Ionosphere divides further into the subregions. D, E, and F. D layer absorbs Lyman series alpha hydrogen radiation, due to which ionization takes place in this layer. E layer absorbs soft X-ray and far ultraviolet solar radiation, due to which ionization takes place in this layer. F layer absorbs extreme ultraviolet of solar radiation, due to which ionization takes place in this layer. Ionization changes during day and night. At night, the F layer is the only layer of significant ionization present, while the ionization in the E and D layers is extremely low. During the day, the D and E layers become much more heavily ionized. During day, the F layer, which develops an additional, weaker region of ionization known as the F1 layer. We have discussed the composition of atmosphere. Now we discuss the effect and role of troposphere in the propagation of radio waves. This area of the atmosphere tends to affect signals above 30 MHz, known as very high frequency and ultra high frequency. It might be thought that signals at VHF and above follow a straight line path, known as line of sight path. So the distance traveled by radio signal of VHF, between 2 points, will be minimum. This is not strictly true, and it is found that there is increase in distance traveled by radio signals of VHF. It is due to the variation of refractive index of air with height, and hence the bending of radio waves take place. So they cannot travel along straight path. It thereby extends the distance traveled by the radio signals. The ionosphere is a particularly important region with regards to radio signal propagation and radio communications in general. The ionosphere acts as a reflector for frequencies 3 MHz to 30 MHz of radio waves. Radio waves or M waves above 30 MHz are passes through the ionosphere. During daytime, D layer of ionosphere exists. Lower frequency, LF, radio waves are reflected by D layer. Medium frequency, MF, and high frequency, HF, radio waves are significantly reduced in strength within the D layer, as these frequencies are absorbed to some extent by D layer. E layer can only reflect radio waves having frequencies lower than about 10 MHz during daytime. The F2 layer remains by day and night and reflects sufficiently high frequency radio waves more than 10 MHz. This table shows the role of different layers of atmosphere for the propagation of radio waves. Now answer the following questions, which is based on the discussion of this session.